Once again, welcome all. A very good morning to all of you. I'm Namita Goel. I'm the channel manager of Red Hat Business at Redington. We are very fortunate to have this webinar presented by Consol Meena and Microsoft directly. Today's speakers are Malte from Consol and Ms. Agnes from Microsoft. Consol Meena, a quick introduction. It is a subsidiary office of Consol Software GmbH, having headquarters in Munich in Germany, having more than 6 offices worldwide. They have established their regional office in Dubai since 2010 with the main focus to support the customers in the MENA region. Frameworks and DevOps practices in the region. In addition, they have enabled a large number of customers in their digital transformation journey using the best use of different technologies, just like Microsoft, Red Hat products portfolio, especially on Azure, Openshift, JBoss, and Ansible. Is the technical director of Consol Meena. I'm really truly blessed to have a whole group with more than 20 years of experience. He's one of the main contributors in a lot of open source projects and working with multiple platform and enterprise systems. Europe and MENA region like BMW, Global, DHA, etc. We are also truly blessed to have Agnes as a speaker for this webinar. Ms. Agnes is a senior solution architect working with Microsoft OCP team, also called the One Partner team, with the focus on vendors, alliances, and ISVs. Prior to that, she was a years of experience as innovative and senior technical leader with different vendors in Europe and MENA region. So, Malte, I would like to pass the baton to you.
Hello, everyone. Can you hear me now?
Yes, Malte, good to see you back.
Good to see you.
Okay, let's start.
Let's start. Everybody sees the PowerPoint as well, the presentation? Yes? Okay. Sorry for the technical glitch. It can happen, but we are agile, and so we just turn it off and on again. So, welcome everyone to this webinar today about OpenShift on Azure. And I'm very thankful that we got the chance from Microsoft and Redington to present today about this. And just wanted to say it's more important than ever that during these times of challenges, people are enabled to use all tools at their disposal for digital transformation, for smart working and collaboration together. Now, Azure is present now in this region with 2 data centers, and their excellent infrastructure and services are creating a great foundation to build on and create fantastic value and applications for our customers. Now, to say short words about Consol, Namita already said a few words. We are founded in 1984. We have more than 30 years of experience in the Unix and enterprise IT sector. We are working all over the world with offices in San Francisco, Poland, Germany, UAE since many years. Our specialty is already said enterprise Unix system. And we are guiding and leading customers on the way how to enable the latest technologies there, how to create world-class, reliable, business infrastructure. Now, since many years, we are also deeply engaged with Red Hat. Since we were also one of the early adopters of Java and JBoss application servers. We got very deep involved with them. We have a good interchange. A lot of guys from Consol went to Red Hat and the other way around as well later on again. So we have a good relationship, very deep and nice. And now we're building the same together with Microsoft, and we are very, very happy and proud that we can do this together. Now, in today's webinar, we'll talk a little bit about Openshift as a trusted platform, then about Openshift and Azure and their partnership, then short words about how you can actually enable your developers to work better, faster, with less friction using Openshift. Then we will have a demo fitting the purpose with showing the ease of facilitating Azure and the CI/CD pipelines using Openshift. And then we talk about creating value and how you can make your applications faster, secure, and scalable, facilitating the same infrastructure and the same tools and services. For that, we will also have then a demo, a little bit more comprehensive, full microservices enabled application that Agnes will build in front of you from scratch using this agile methods. Yeah, all the automations available. We'll talk a little bit about the subscription model and the sizing, and then we will have, I think, a larger question and answer section as well, of course, for everyone. Now, it was not too long ago that a few of you might still remember when Steve Ballmer went on the stage and said, open source is cancer, and yeah, and Linux is just copying everything. I think we can agree safely that times have changed, and nowadays it's being recognized that collaboration is creating true value in the market and enables us and our customers, and of course Microsoft and Red Hat as well, to create more and better software and to utilize each other's strengths for their own benefit. Satya Nadella actually kicked it off from Microsoft's side, and I think we can agree that with great success since then, Azure has embraced Linux deeply, and this is shown in a lot of different places. So while an example, many years ago, Red Hat was one of the first platforms to be fully certified for Oracle Enterprise Database. Nowadays, even one of Microsoft's own enterprise class software is certified on Red Hat and on Openshift, which is the SQL Server. Now you can see Satya Nadella was even talking on the Red Hat Summit, yes, in May 2019. Okay, so in Azure currently, 50% of all VMs are Linux VMs. Linux is growing much faster than anything else inside their data centers. And on top of that, Microsoft is even #5 contributor overall for Kubernetes, which is the underlying containerization framework where also Openshift is built on. Now, to understand why this is a very good match between Red Hat and Microsoft, you can see that Actually, already 95% of the Fortune 500 enterprises in the world are using Microsoft Azure. The likes of, you see, Anthony Young, Ford, Lufthansa, Samsung, Toyota, and BMW, yes, and many more are using these services, as well as 100% of the Fortune Global 500 companies in airline, telecommunications, healthcare, and commercial banking are relying on Red Hat. I can add on top that automotive sector, insurance sector, and many more are embracing this as well. And it's not just because of Red Hat itself, it's the security, the stability, the long-term performance that it gives. So now the mutual benefits between Microsoft and Red Hat Enterprise are clear when you see that this is creating cost savings and operational efficiency. You have the same standard OS across all your platforms. So, I mean, we're talking about OpenShift. You can actually start your own containerized environment in your on-prem or even in your own laptop if you wish to, with just 1 or 2 VMs, maybe 3, with an OKD or something just to test it out. I think every one of us has now already heard about containerization and containerized workloads. So the benefits of those are obvious. You have one OS in that you can abstract this completely from the underlying infrastructure. So you have your container running Node.js, running Java applications, running Python workloads, or anything, and exposing a RESTful web service, and you just package it into a container and can easily deploy it across, and you don't have to worry about if that underlying platform where you run it will support your functionality, because that's by default a given. And even better than that, you can package your configuration and deployment packages in a separate way. So you can, let's say, have the same software package that you want to deploy on production and run it through staging development by, let's say, creating an example, separate volumes for your configuration of your application, and then just run the container deployment without touching the configuration itself, actually. Now, Red Hat on OpenShift is Red Hat Openshift on Azure is actually giving the platform to fully deploy enterprise class architecture with huge scalability potential and enough resources to even dynamically scale up the largest applications that you need to support too. And, yeah, without suffocating on the demand, or you don't have to worry about that. The load that your customers are generating is taking down your infrastructure or anything like that. Same is for SQL Server on Red Hat. That with Microsoft together, they have created a hybrid scalability platform there. You can easily scale your database across the Azure infrastructure. With SAP, of course, the same. So the real value of OpenShift is, as we said before, this abstraction of the actually software itself and the underlying infrastructure. So in the moment you containerize and you have different teams all over the world supplying software to you. You need to make sure that you have one standard. And this standard compliance, I can tell from years of working together also with BMW, is a huge thing, especially if you have thousands of applications. An example for BMW itself, just for the part that is dealing with cars, they have more than 1,000 web-based applications. The whole section is called B2V, and it's only, I would say, around 10 to 20% of the overall applications inside BMW, which all of them are Java-based, by the way, or the majority at least. So they had very strict guidance and guidelines on how to develop your applications, what frameworks to use, what memory you're allowed to use and allocate for yourself, and still every day there were hundreds of issues all across these, and I think everyone who has worked in large-scale operations can tell the same. It takes effort to really control this and make sure everything is running smooth and scalable, and there are no issues, particularly because, as well, I mean, in that time we were talking about monolithic applications with a deployment maybe every half year or something. But now we are, I mean, the world has changed, the paradigms have changed. We are having now agile deployments and incremental releases that can come in a 2 weeks rhythm. Just following the pattern release often, yes. So to support this, there would be, in other circumstances, there would be a lot of governance to be taken care of, a lot of issues popping up, a lot of control to be applied. But since those organizations, and BMW especially is an example using Openshift, they can not only abstract this from their developing teams, they can also abstract the infrastructure itself worldwide. So let's say they have a huge data center in Munich, and for sure they started implementing Openshift in the data center in Munich, but they also have operations all over the world in the US and Spartanburg and in other countries. And instead of building up new infrastructure everywhere, they can just easily start and they have actually started to create an Azure Openshift installation, and they can just from Munich run their build pipelines and directly deploy there to their convenience. And this is reducing the friction and the coordination between all these teams and between operations, between developers, between the InfoSec department, and it's tremendous. The economic benefits of this are enormous. Now, creating value is actually also time, yes? Because we know time is money. So in the moment, you can apply lean processes, you can remove all these frictions. You have, let's say, cloud native applications. Let's say you have your Node.js RESTful service. You have now Python-based machine learning. You have Python analytics. You have some Internet of Things with some MQTT gateways or whatever. It's all open, and you just create the base standard on what platform it is running, which would be a containerized environment, and eventually a standard, the container should have CoreOS, right? But the rest, which exact version, it's all abstracted. Yes, of course, we encourage everyone to update, but in general, this supports the culture of innovation and allows enterprises to scale. which in terms allows them to be more innovative, to react faster to market trends, to listen to their customers, to have a proper feedback loop between what they want to achieve as a company and enterprise and what their customers are expecting from them to do. And specifically, also in this region, we have a couple of examples. When companies are trying to implement Kubernetes themselves, it's extremely complex. The networking parts and the policies are not straightforward, and you need to have a lot of deep insight know-how in order to overcome all these initial challenges and to build it up. Now, this is all taken, let's say, from you, because Openshift, specifically Openshift 4, has, and as we will see, has a very nice installers and configuration utilities that will take all this from you and then collaborate nicely with Azure as well. So you can, it will, an example, you define your networks in Azure and will just check against this during installation time and verify that it is workable. And that's it. It's very straightforward. So there's, as we said before, it's not only that it should be easy to work with Openshift, it should also be easy to maintain and operate it. So, and if you can identify a blocker in a company, you know very well we should remove it. And this is what Openshift is doing for operations, for developers, for enterprises, and together with Microsoft, with Azure as a platform it's running on, it makes a tremendous job in this regard. So it supports templating, it supports all the validation, as I said, it will set up. And you have to, in a proper Kubernetes done by hand, you have to define your identity security access, your app monitoring, alert, storage persistence. You have to understand your egress and ingress routing and your host container images, and you have to define the build deploy methodology. You have to know exactly what kind of networking you want to put up. You have to make sure that it works together with your infrastructure, even if it's cloud-based. But all of these things, log aggregation, an example, also when you operate, or it's not even, one of the most challenging tasks in operations is also keeping it nicely running, updating regularly, make sure that the principals, the customer, are not feeling any interruption of service, and they have a smooth operation, but still it's secure, and and you need just to make sure that this is a functional enterprise environment, right? I mean, it's the same as, everybody's talking about backup, and they're saying everybody wants backup, but nobody wants restore. The same is an example true for upgrades. Yes, everybody wants to be secure and have the latest updates, but no one wants to install them because that means service interruption eventually. So Openshift is doing a great job and taking this from you, and especially with the complexity of this distributed systems, it is helping a lot. Now, containers, as we know, come with their own challenges. So container security is a thing. I think few of you heard that while adopting containers, that a lot of containers are actually unprotected. And this is, this is also a big thing now. I mean, it should be easy, of course, but also it should be secure. So Openshift is also taking care of this, and has specific patterns of container security checks, and is scanning actively for it, and it's eventually patching it and checks for compliance. And of course, we have all the monitoring, dashboarding, the surveillance, we have the install upgrade, the integration, and so on. So Red Hat Openshift on Azure is a trusted enterprise Kubernetes. It is really an enterprise class software that fulfills all the needs of an enterprise without taking the complexity a bit away, while not not taking the flexibility away, but the complexity. It gives a cloud-like experience, and you can concentrate on that, what you're doing best. That is developing amazing software that encourages your customers to facilitate your services. Now, Red Hat is not only OpenShift. The open source innovation is also about Zeph, distributed storage, about etcd, it's another service to store your encrypt your credentials in a secure way. Kafka as a stream processing, Spring Boot, we heard about it, Node.js, and so on. It's a whole ecosystem. It's not only one single application anymore that does it all. It's an ecosystem of interacting services that together build an enterprise ecosystem. And OpenShift is the glue that brings it all together and creates a real value there. Now, Azure Red Hat OpenShift is together engineered. So when you're running OpenShift on Azure, you have different models available. One is you actually facilitate the Azure infrastructure, and you are using your service and build up the OpenShift cluster with your own license. And for that, there is a tremendous amount of support. Of course, it's all supported by Azure, and this is one of the best ways to install OpenShift on Azure as well, specifically if you want to scale it up to a larger environment. However, of course, Microsoft has engineered together with Red Hat a variant where they jointly support it. So you can pay as you go, run OpenShift on Azure using your existing subscription as well. I can show you now an example. It can work that in this model you see the typical in this region supported way of OpenShift on Azure. You will provide the user management, project quota management, application lifecycle, cluster creation, cluster management, monitoring, logging, network configuration. This is all coming from OpenShift. So that means since you will just facilitate Azure Premium SSDs and the compute and worker nodes, but you can use the Azure load balancers in between and the Azure DNS, and Azure integrates the Azure Active Directory for your EIM, identity and access management. So it's a very close ecosystem there as well already. Just here on this particular example, this is giving you the the benefits of both. You have full control, but you have to operate the OpenShift as well. If you plan on a larger deployment, this is most likely the best way to go for now. Also, I have to say that the Azure integrated OpenShift is unfortunately not yet full supported in this region. That I mean, yeah, we will come later to it. That will be if Microsoft and Red Hat are jointly together managing the clusters and operate the VMs. Then in this example, it is simplified. It's also nice, and you can have this as a pay-as-you-go. And it takes a few more burdens from you, but in certain circumstances, the customization options are a little bit less than before. However, for a lot of scenarios, it will work nicely. To work your OpenShift with your own license on Azure, the easiest way is with bringing your own subscription currently, and you will create a golden image. And from this golden image, you can easily facilitate the Azure templating options, and an example is Terraform, create new VMs as you go. So now if you use the capabilities of it, you can create this multi-cluster management layer on top. You have eventually not only the Azure OpenShift, you might as well have your on-prem OpenShift. You can, of course, with create your virtual private cloud and connect those with a VPN to your local on-prem data center and combine those. So that moment you already have a multi-cluster. You have a local cluster and your Azure-based cluster. You can shift the application between them. Now, the platform services that you retrieve from this are service mesh, your sidecar proxies that will allow you to do properly.
Martha, I think, what do you think it would be? I think a good time to show the audience how to install and run OpenShift on Azure.
Okay, we can do that now. You think you're, yep.
Alrighty. So as Martha said previously, there are two options for you guys to run OpenShift on the top of Azure. And today I would like to show you the IPI version, which means that you are in control. We are using the Abu Dhabi data center for that on the top of Azure. So as you see, I am using right now an Azure subscription, and this is the Azure portal. And in the first part of the demo, I will show you how easy you can right away install OpenShift on the top of your compute resources here in the region. So in order to do that, you have to have an Azure subscription. And from the Red Hat portal, you can get a 60 days evaluation subscription for the OpenShift. And you can very easily start and consume it. So just a question, I presume that at least on a very basic level, all of you guys are familiar with the Azure portal, so that at least you heard about it. Some of you may be running already businesses of it. What you see now, this is the Azure portal. And when I would like to install OpenShift 4, which is right now OpenShift 4.5, I need some steps to do first on the Azure portal. And then I would need to have, I need to just run the Azure installer on the top of the Azure subscription. So one thing before you start, every subscription in Azure comes with limits. Usually the vCPU limit is 20, and if you want to run OpenShift or any other services, you might want to increase the vCPU. It depends on which Azure subscription you have. You need to check if it is pay-as-you-go, it is 20. If you have an enterprise subscription, then the limit is much higher. So first of all, in order to install OpenShift, you need to get the installer. So OpenShift OpenShift Installer comes from the Red Hat Openshift Cluster Manager, and there are two ways you can install on compute the OpenShift. So one is the so-called IPI installation. This is when everything is automated for you. So as you can see, these what you see here are all infrastructure providers for OpenShift, which means if you guys can do copy and paste very quickly, it's 15 minutes. If you read the documentation as well, then it's like 25 minutes to install on these infrastructure providers, the OpenShift. So we will be using Azure, and here, as you can see, there are two installation types. So we will be using the installer provisioned infrastructure. Why? Because this is the most convenient. In this case, the installer will provision everything for you. Everything. I mean, really configure Azure services, the compute, the storage for you, the underlying network. So in order to do that, you need to, first of all, download the OpenShift installer. The OpenShift installer comes either on for Linux or Mac OS. Sorry, Windows guys. So, this is a couple of megabytes, and basically it's a collection of Terraform scripts to automate the installation. What you also need to do is basically to have a pull secret, because the OpenShift 4 installation is pulling the images for the OpenShift from Quay.io, and this is the pull secret you will need to have. And then you just go and follow the documentation. So first step, you click on the download link, and then you also obtain the secret for the images. Once you have done that, the next step, you need to do two things in your Azure subscription. So first of all, this is easy. In order to use the OpenShift, you need to configure a DNS for that. This is my playground DNS, vodiva.com, and I have assigned this az.vodiva.com to the Azure DNS. And so, for instance, if you are a customer, your company already has its own DNS services. So you might want to allocate a DNS zone for your OpenShift. What you need to do, so for instance, what I had to do with my own DNS in order to function, I have pointed out on my own DNS server the name server of the Azure, so that they know, so that my name server knows that, or DNS service knows that the Azure will take care of this domain name. As you can see later on during the installation, the OpenShift installer will create the records under this. So this EPI.osdemo and the wildcard DNS, what you see here, are all created by the installer, so not by hand. So first of all, you need to set up the Azure DNS. You can do it through the portal. The other thing, what you need to have in the installation is basically your service principal. The service principal in Azure is basically an authenticated user where actually you can use this in order to manage and manipulate also Azure services. So this is how everything can be automated. And as you can see, I just need to hide this, load more. So what you see here is actually the Azure Active Directory. This is the identity service, what is used within Microsoft in order to host and also to use these service principles. So before the installation, I have created the OpenShift _SP like service principal. I was not that creative with the naming, but you can name it anyway. So for instance, if your company already has a logic how to name the service principles, then you can use it. So you create the service principle, you assign these roles to it, and you are good to go. So once these two things are set on the Azure side, the next thing what you need to do is basically start the installation. So right now I am using, you remember we have downloaded the installer. So if you download the installer on your Linux or Mac machine, then you will have a utility called Openshift Install. And basically this installer is will be able to perform for you the cluster setup. So I just asked for the help, what it can do for you. So basically what we use from it is creating the cluster, and you can of course destroy your cluster with this utility. So if you don't need it anymore, then you can just decommission it. All right, let's see how the installation goes. So once you downloaded the Openshift installer, the installer is quite straightforward. It will ask you which platform you would like to install on. So you have now the possibility to use AWS, Azure, Google Cloud, OpenStack, OVIRT. This is OpenShift virtualization, by the way. It's a very nice feature. You might want to try it out. And of course, VMware vSphere. Let's go to Azure. So the next question, what you need to answer is basically you need to go and check for the data center. So as you see, this is the UAE North. There is also UAE Central, and you just need to select it. Then do you remember we have to set up the base domain on the Azure DNS. So that DNS needs to be entered here. And then you need to give a cluster name. Just give a cluster, test cluster. And you need to paste here the pool secret, and basically then you hit an enter, and the cluster is created. Approximately, I have tried multiple platforms for the Openshift installer. Basically, it's about between 15 minutes till 20 minutes that the installer finishes everything. So I will not start this right now because I already have provisioned for you this cluster. So how does it look like from the Azure portal perspective? What do you see when you deploy the cluster? So let's go now to the dashboard. So this is the Azure portal's dashboard. As you can see, here the Azure portal gives you the all resources view, and we just click on it. And here you can actually assess all the services and all the objects what the installer has created. Let me just group it by type. It will be easier to read. So first of all, if you are not familiar with Azure, just that you see Azure is using so-called resource groups in order to group together logically all the services and objects what belong together. So in our case, the installer has created an OS demo xadx-rg. So this rg is the resource group, and all the cluster-related objects are within this resource group. It is very good. You might ask why is it why you are not want to use one resource group for all the clusters. Later on, from Azure perspective, the resource groups can be used also when you would like to extract the cost of that particular, for instance, Openshift cluster. So how much resources it has consumed from your Azure subscription. So here are these are the disks what have been created, and as you can see, this is the DNS zone, and it creates also the load balancers. It creates the identity, the managed identities. This is actually a service principle what was created by our installer in order to run the Openshift cluster. The network interfaces, the network security groups, of course, the necessary public IP addresses, and the virtual machines. I will come back to the virtual machines a little bit later on. But just to point you back, if you remember, I was advising you that before you start the installation, you might want to check your Azure subscription, how much vCPU is allowed in total in that subscription. So this is actually why, because the default installer will create for you 3 masters, and they will create for you 3 worker nodes. As you see, you have I have here already 4 because I scaled the cluster. I will also show you later on that. So this is the Azure side. If you would like to try out, if you already have an Azure subscription or your company has an Azure subscription, then you can use this portal, and it will give you a 60 days trial. And in this Openshift cluster manager, you will also see your clusters. These are also my playground clusters, and you see that it has a 60-day trial. So this is what you will see if you just want to try it out. So let's see what is created. So this is my this is the Openshift 4.5. I am now logged in as the administrator, so I can have an overview of my cluster, and you can see what is running here. So I have in total 7 nodes. As you remember, I have 3 masters and 4 worker nodes. You see how many pods I have up and running, what are the storage classes, how many PVCs I have, how many storage claims I have, and I can have also a project view. Right now, since I am an administrator, I can basically see everything. So, all right, you might ask me that, okay, now we have this Openshift cluster up and running, then what I can do with it. So after you have installed, you can start right away to develop on the top of Openshift. You can create projects and then start right away to deploy your application. Let me show you this sample application, what I have created in the first part of the demo. So I will just show you what it does. The first demo is a very simple basic application. We have a Node.js front end, and there is a MongoDB backend. So what you can see here is basically the routes. If you remember, Marta explained to you that if you have a planned Kubernetes, you might need to have a plan how you would like to manage the networking, how you would like to expose your applications, etc. And apart from I will also highlight you later on. One of the good things and very nice things from Openshift that it comes with its own software-defined networking already enabled. And for instance, exposing services and creating routes for like the ingress is very easy. It's already built in. So what you see here right now, the dashboard, the console, this is how Openshift comes by default when you install it. So this is the application. I show it to you. So that's a boilerplate application right now. Don't worry, we will be also having a more complicated application right now. So this is a Node.js application. And as you see, it has actually a page count. So this number is coming from the MongoDB. Let's just have a look at this MongoDB. So I am going to the workloads. I can select the pods. And as you can see here, I have, let me just group it by status. I have 2 pods running right now in this project. One is the actually the Node.js application, and one is the MongoDB itself. So where does this actually how does Openshift know how to deploy this application? So how this application came to this Openshift cluster. So in order to show you that, let me just go first to the builds. So let me just show you the build configs. So I am here in the OS demo, and this is the applications build config. So if I am clicking on that, you can see that this is the build config is basically the information what Openshift is using to build the application. And later on, we will have a deployment config in order to deploy that application. So as you can see here on the website, we are using webhooks. Right now, the source of this application is residing in a GitHub account. And I was using, so this is the Git repository where the application is there. And when you would like to actually deploy the application, you need to have a webhook from your Git repository to your Openshift in order to have all your changes or commits what you make in the repository reflected later on also in the application. So right now this is my application, just that I show it to you. So if you remember also what Marta explained to you, that BMW has thousands of applications, and one of the main reasons why they have gone with Openshift is basically to have this very rapid pace of application development, where if they would like to make a change, then everything happens automatically. So one of the things what Openshift comes with built in is a source to image capability. This means that it can take the source, like my source is now on the Git repository, and it can do directly a build from it and deploy it. So this means that so the expectation is right now that if I make a change on the code of this Node.js application, then I would like that Openshift automatically does the build, and it also deploys the application. So let's just see. I am just showing to you. So this is exactly the same GitHub repository what I am using with the application. So this is a boilerplate Node.js application, and now I will make a change to it. So let's just go here. This is the index.html, what is displayed there. And let me just make a change. All right, welcome to Red Hat. And this is the Openshift on Azure webinar. let's just commit the changes. So this is the commit. So just remember that this was my original version. Let's just go to the builds. Just to show you. So this is exactly the same. So right now, this Git repository has a webhook to the Openshift. And as you see, I haven't done anything. So because the webhook is there, once the change has been made, a build has started. And from the Openshift portal, I can also access the logs. Let me just expand to you so that you see it. So this is what is happening during the build. So first of all, there will be a new image created, and the engine will also populate and install the npms. And after that, it is pushed to the registry, and then it is deployed. Let me just show it to you. So yeah, these are the npms. They are coming. Yeah, and as you can see, the push, just as you see why I was zooming out. So it says the push was successful. This means that we have a new image. And if I go now to the deployments, the deployment configs, you see that I have a deployment config for this application. If I am going to the pods, then you will, I hope that I was quick enough, hopefully. Let's just see. Yeah, I was not quick enough, so the Openshift was more quicker to reflect the changes in the application. So basically, it had run a deploy pod, and it was basically refreshing the application on the fly. And as you can see right now, this has been refreshed. So just to be clear, I have only pinpointed the source to Openshift, and you can ask me, okay, but how does Openshift know, for instance, that this will be a Node.js application? Because you haven't, we haven't actually configured it explicitly. As I said, we just shown it to the build config that yes, this is your source. So basically, what is happening in the background, and I need to show you the code for that. So if I am coming here in the Openshift, you will find this nice pipeline. I just want to show you this this Jenkins file, and as you can see, this Jenkins file is actually says that this is a Node.js, and this is how you build it, dear Openshift. This is how you deploy it, and basically Openshift automatically takes that and starts Jenkins in the background, and then deploys the application for you. There are, of course, you can tell me that, okay, this is very nice and good, but most of the customers here in the UAE and also in the region, they are using for the pipeline some dedicated software, and they are building up a CI/CD pipeline for that. And you can ask me that, okay, but what about if I have, for instance, Jenkins? I mean, I have my own Jenkins, and I would like to have, I need to do more sophisticated pipeline functionalities, like, for instance, test or integrate with an approval system. How do you do that? So first of all, it's very easy, and this will be the main focus of the second demo with the microservices application to show you how to do that. But just as a spoiler, I show you that today, with the second demo, I will show you how to build up the CI/CD for a microservices application. Let me just go to the workloads. I am selecting this project, and here you can see that I have right now here a Gox. Gox is basically like Bitbucket. It's a Git repository. I have also a Jenkins up and running and also a Nexus. And the goal is to have a Jenkins up and running on the top of Openshift and do a CI/CD for a microservices application. So just as a ramp up, in the first half of this demo, you had seen how easy it is to actually install on the top of Azure Openshift, and I have also shown you how to use the built-in source to image to your with your Openshift. So I am giving back now to Malta.
Yes. So thank you very much, Agnes, for this amazing demo. So one moment, I'm just putting. Now, as you can see, Agnes already showed the benefits of Openshift for developers, and I just want to run you quickly through this. So you can see developers have are more productive, have a choice of architectures, programming languages, databases, application services, development tools, and they have also a choice of build and deploy workflows. So they don't have to worry actually about the infrastructure itself. And as Agnes already explained, there's even something better as a built-in CI/CD pipeline with source to image. They can directly build your images from the source code directly from your repository. And then you have the artifacts as well. You have a Maven, you have the Nexus, you have built-in Jenkins. But I mean, you are free to choose if you want to have your own Jenkins, your own Nexus. You just can spin it up, and this is also the part of this ecosystem. So you see, for all these different particular parts of the pipelines of application infrastructure, supporting infrastructure of routing, service requests, and so on, there are is a huge landscape of possibilities actually at your fingertips. So this Red Hat Openshift ecosystem. Third-party software is certified, as we already said. It's certified by Microsoft for MS SQL on Azure. It's certified by SAP, by IBM. Have the cloud packs available. Then you have F5. F5 has now Nginx, and Nginx is famous for the WAF and F5 for the WAF, and they ported it now to Nginx as well. So this will be also available now on Openshift on top, and you can use this. You can have Zabbix monitoring. You have Couchbase databases. Everything is there. Agnes already showed in the installer. You have Azure, you have Google Cloud, you have Amazon Web Services, you have vSphere, of course, available as well. And we are running this in our office as well. We are running an example. We have a hyper-converged vSphere cluster for our development in-house in UAE, in Dubai. And we are running our Openshift directly on this hyper-converged infrastructure, which is amazing. It's scalable, nice, fast, it was just very impressive how quickly and easily it was possible to set it up. And then from there on, you have all the Red Hat portfolios at your hand. You have the message queuing, the AMQ, you have the BPM process automation, you have the API management, 3Scale. 3Scale, of course, runs also natively on OpenShift on top and is able. You can commercialize your APIs. You have maybe you have heard about the API economy already. 3Scale is one of the top tools to use there to expose APIs, to secure them, and to account and interact with third parties. Now, as we said already before, developers need to really focus, and they can only focus and increase their productivity if they don't have to think about all the other things. And as Agnes already showed, it's super easy just with OpenShift on Azure to transform the changes in your source code to working functional applications that are immediately scalable and workable in OpenShift. Now, of course, you can define your deployment workflows as well. So if you, let's say, want OpenShift to and you have a little bit of support from your application itself to do it, you can do blue-green deployments and whatever you want. This is absolutely fine and can be fully automated all through the infrastructure. And that means, an example, you can enable your developers to, let's say you have different environments, you have built your CI/CD pipelines for stage and dev, and maybe another test system for the automated tests. So your developers will be able to run their CI/CD pipelines automatically and test the application in the same environment or similar environment as on production. And since all of them are running on OpenShift, it is almost guaranteed that it will work on production itself as well, because really it is only the eventually just the configuration, let's say URLs or what username for which database has to be different, but that's it. The rest is completely the same one-to-one. The image will be shifted through and deployed on the other environment as well. It is really removing a lot of friction. On top of that, you might wonder as well, in OpenShift, generally in containerized environments, people are saying you have eventually the problem with understanding what is really going on inside your application. But I think Agnes already showed the log stream from OpenShift, and similar, it is actually available for the containers itself. So OpenShift is aggregating the logs for pods. So you have an overview about the actually activity of your containers inside in a central place. So if you have 20 containers doing this, running the same application, and you also will struggle to find out which one has now processed which request in a traditional environment. But now it is all aggregated and you have a matrix for it, because OpenShift also provides a sidecar proxy, which, just as a short explanation, is basically exposing the service itself from the pod before it is exposed to the outside. So you can trace requests through all the services in between OpenShift and from the outside. So you know exactly, okay, who has requested what and what service did interact with what other service and how long did it took, and what at the same time, how much resources did this request take, and so on. Now, Agnes already showed how easy it was to set it up, and she did actually. She created a new endpoint to expose a new project. So we can skip this one. You have the developer console as well. You see how your microservices are supposed to interact, and you can create a topology, and yeah, you can see and the pod logs, and you can see how these workloads are interacting with each other. This is really helpful, and again reduces friction. I mean, these are typically tasks that operations has to provide as well. Imagine this as well, like let's say you have a developer role on production, and you can easily give developers the access to at least view some of the logs and some of the metrics, so they can understand how their application is behaving and quickly address any upcoming issues before it transforms from an issue to a problem, actually. As well, then Openshift comes with the code-ready Workspaces, which is basically web-based development environment. And now we have source to image. We have this code-ready workspace, and you don't have to, let's say, you can now use any device that has a web browser and develop software from there and run it and trigger the pipeline. So you don't have to, let's say, build your WAR file, then upload the WAR file somewhere, then copy it into and put it into the right repository, run Maven, then alert to operations that now the WAR file has been uploaded or whatsoever. It's all gone. Of course, if you have your traditional development environment as Visual Studio and so on, it's fine. You can integrate as well as of course the Azure pipelines are now in code ready as well as available. So if you prefer Azure DevOps, it's also possible to utilize. But similarly to the GitHub Actions, or yeah, you can just imagine this is search and ease on the CI/CD pipelines. Yeah, just a sample how to create a new application with a Wirefly application server, or you can see the PHP front end. It's just taking, again, the friction away from developers. And I don't want to go too deep into this, but there's another new functionality. This is serverless. So while you saw that in Agnes' demo, she had two pods running. One was a MongoDB and one was actually Node.js application. They were already running and consuming resources. But we understand, since everything is on demand, why would there actually be someone needed to sit there and wait for a request and like fully run it? Why is it not possible to even cut it down and say we wait for the first request and then we build it up? So, and since Openshift sees all requests because of the underlying routing infrastructure, and now with Knative, it's actually possible for Openshift, and depends of course on your application, but if your infrastructure is capable enough, basically Openshift can scale down to 0 and start your application on demand. You have seen how quickly Agnes image was deployed and the container started. It's typically far below 1 second that is needed to spin up a container. So you can see maybe if there's a not very often used application, you can make sure it doesn't use any more resources and scale it down to 0. And then just the first request that will come to it will maybe take 500 milliseconds longer, but then it will be up and running and fine. Surely you can integrate this also with Kafka, any stream event source and so on. Also, of course, Azure Functions, yes. There is something famous. I actually wanted to put a picture in this. It's called the Microservices Death Star, which became famous after I think Netflix published a picture of their approximately 500 microservices and how they are communicating to each other and to the outside. It is a little bit scary, to say the least, but with Openshift and Openshift Service Mesh, it comes with tools along to structure exactly this request and to make sure that not only from the application logic and request logic, but also, let's say, from security perspective, you can generate policies that that will allow exactly one microservice to talk to the other. So you have very defined and narrow policies. Almost, yeah, you can imagine like the typical strict network separation and policies where you have a deny all policy first, and then you allow just one node directly to communicate to another. Only here the difference is, of course, since everything is flexible and scalable, your firewall admins will run crazy, because whenever a new container will spin up, they would actually have to fire up the firewall rules again and bring them down, block again, and so on. And but if you use OpenShift, you don't have to do that. Once you define the policies properly, OpenShift will take care of this for you. And speaking about security, I have a little bit of background there, but when I read this, I have to say it was both impressive but also scary on the other side. It's so quick that you need to make sure that you still have proper tools in place to not create a shadow IT, let's say, where developers are creating new applications and exposing eventually data points, and IT ops and InfoSec team doesn't know about it. But nonetheless, in an ideal world, they are all working together, and you can see here an example. The ideal way would be the developers submitting the code into the repo. The CI/CD pipeline will write it into the registry, create the image, and then by the means of Ansible or OpenShift, it will be automatically deployed into Kubernetes. And the ops team is actually sitting there and making sure that these pipelines are working smooth and the configurations are fine, and they merge it together and monitor this. So if anyone from operations is afraid that there is no more work for them, nope, that's not true. It's shifting the focus away from let's say from micro-managed task to a broader picture, more similar to developers, that require longer planning sessions ahead and proper planning, but let's say the mechanisms itself give more flexibility and also convenience also for operations. With microservices infrastructure and applications, the amount of services can easily scale up to a few hundred. And as we heard now, I told you before about BMW. It is 1,000 and more web-based applications. Each one of them has their own stage and integration and test and development environment, of course, as well. So then you may want to, let's say, if production is running at least on, let's say in the traditional terms, production was always running on 4 nodes. You may want to make sure that now your your new service is also running with the same kind of, provide the same kind of resources. So you can define an OpenShift and say, yeah, I want to make sure that there's at least, if it's a very frequented application, there's at least 2 or 3 containers ready for receiving a request. So you may want to make sure that your application is actually supporting this as well, even if it's, let's say, typically stateless, and RESTful. So you want to have the same resource allocations in staging as well. The amount of running containers is huge, yeah. But you can, if you have the, we will come there, I think, soon, that it's not yet clearly announced when Azure will support the native OpenShift directly as the collaborative approach. But once this is done, you can see that it's even easier with AZ arrow create. But yes, so we can conclude we have from IT operations, secure, efficient control processes. There's a huge amount of automation available, and security scanning, automated backups, upgrades, and so on. Okay. I'm talking a little bit too slow. Let's skip just the Ingress point. Yes, okay. I just want to say we have now the Operator Hub launched by Red Hat, Microsoft, AWS, and Google. Operators are a new concept in OpenShift 4, and they are basically automating regular operations task in OpenShift. Again, helping to reduce the friction as well for the operations team. Now, why Consol can help you in this? We said before, we do everything from, you will receive everything from one experienced hand. We are a long-term Red Hat partner. We have done this multiple times. We work from embedded systems to real-time API to multi-continent distributed systems. We are a huge open source contributor. You can check our website as well, labs.consol.de. This region, we are Red Hat Advanced Partner, in Germany Premier Partner. We're working on getting Premier here as well. We're also Nginx Partner. Yeah. So we can guide you all the way through for your OpenShift requirements. We can set up a workshop. We can see and make sure that OpenShift can meet your expectations also in practice. We can build together an OpenShift POC for you and tailor it to your needs and requirements, and make sure that this journey is fulfilling really your needs. We can also help you and help you create new applications. We can help you with application architecture. We can help you with the software itself. We can help you with the CI/CD pipelines. We have developers in UAE available that can guide you there and do this. We can train you as well. We have the OpenShift expert at hand. And we can also provide operations and support in English, Arabic, Hindi, and even German to customize to your needs. We are also specialized in monitoring and will be able to support all your monitoring needs and reporting back. And this together with the OpenShift tools, of course, as well, to have one holistic tool and view to all the infrastructure and containerized environments that you are operating. Now let's go back to Agnes and follow her next demo.
Alrighty. So let me just go to the second half. So just to connect to Malte's previous flow. So as you had seen, when it comes to OpenShift, we are supporting a lot of setups when it comes to CI/CD, and one of the things why we are doing it, because most likely we will need an automated build and deployment system. And one of the things why is it a hot topic is that right now the pattern for the applications, what we are suggesting to our customers to take is that they are implementing microservices architecture. So you might want to ask what is actually microservices architecture, and in order to understand this, I would formulate it that the microservices is actually an architecture where all the components of the system, what you put together from these individual boxes or Legos, and you can build it from these components, and you deploy them and scale them and build them individually. So why this is very important? Or you would ask me, okay, but we have done monolithic or normal multi-tier applications since ages, and actually it was working okay. So why companies go with the microservices application architecture, like what you see here? So actually, I would like to ask you some questions. So first of all, right now, if you look into your own, let's say, development or into your own operations, can you do, for instance, can your developers make anytime a change to your applications? I bet no. Or for instance, would you be able to do simultaneously multiple changes and scale your application components accordingly? Or for instance, how do you choose your development tools? I mean, why do you choose, for instance, Java for something, or why do you choose a certain development tool? One of the things what I had always in mind when it comes to IT, that it's like you need to choose the right tool for the problem and not the problem for the tool. So, and this is, I think, also one of the drivers that you can have a hybrid technology landscape when it comes to development. Like, for instance, some of your applications are in Java, some of them is Node.js, etc. Actually, the fourth thing, what I had seen our customers to consider when it comes to the microservices architecture is that it gives them a fault tolerance when it comes to the overall system functionality. So, for instance, if you have a problem with one of the functionality, will this take down the entire application, or you will continue just as normal, and only one friction of your application functionality is affected? So these are the things what you can or you might want to consider. So what you see here right now is the application, the microservices application, what I brought to you today. It is called the Cool Store application. So just that you see, so for instance, you are a customer, you just started, you, for instance, got Azure subscription. And even if you are a bank, you would might think about, okay, what should I do with this Azure subscription, or what should I build on it? And one of the popular patterns or popular applications, what you can do is actually, a very basic e-commerce website. So what you had seen there, this microservices application, this Cool Store, is actually like a skeleton for an e-commerce website. As you see, we have multiple services here. You can buy a fedora, you can buy stickers. If you like, you can have T-shirts, whatever gadgets you have, and there is a rating included. You can add it to the cart. For instance, I am totally into the fedora. I want to have at least 5. Yeah, I want So, and then you can go here and you see that this is the total amount, and then I can ship it, etc. So this is basically like a very basic e-commerce website. And if you are, for instance, new or a startup, you want to sell gadgets or whatever goods you would like to have, then this is a pattern what you can use. Let's have a look at the application itself. So as you see, this is basically the Cool Store application. What are the services? What it is consisting of? So let me just go from the front end side. So it has a web UI. As you see, the web UI is in AngularJS, and it runs in a Node.js container. Then we have a Cool Store gateway. This is basically a Spring Boot plus Camel application, and it is used as the API gateway to these backend services. And here, the backend services are basically have their own stack. So, for instance, we have a rating service. This is in Vertex. It uses a MongoDB. We have a Hello, I am. Can you hear me? Can you hear my voice?
Yes, Agnes, we can hear you.
Yes, I think you have to jump back a little bit, like maybe a minute.
Sorry, guys. The thing is that I didn't notice. So basically, what I was explaining here is that we have here in this e-commerce website, we have a web UI in AngularJS. So this is one service, one microservice. We have the Cool Store gateway. This is basically the API gateway for the backend services. And we have for each of the business services one microservice, what is actually the component, what is responsible for that. We have a rating service with Vertex and MongoDB, a review service. The inventory service is a GBoss application with a Postgres, a catalog service, and a cart service plus a pricing service. So basically, as you see, that this functionality here, what I have presented. So this is the application, the system actually, but in the background, it is consisting of multiple microservices applications. So let's see how it looks like from the OpenShift perspective. So just as a little reminder, if you remember, Marta started to explain to you that when it comes to enterprise applications, you guys have, or customers have, a dev environment, test environment, SIT, and production. And basically, in order to have a very smooth and streamlined application deployment and delivery, we would need to have like a CI/CD pipeline. Let me just show it to you very quickly what I mean with it. What we would like to achieve is the following. So you have your development team. So these are your developers. You have a Git server. This can be like a Bitbucket or like a Gogs, what I have shown you. You have an artifact repository. And actually, when the developers are committing a change to your application, then basically the or what we would like to have in our software factory is that we can do an automated build. Then it is deployed, it is pushed to the registry, and it is deployed on the dev environment. For instance, on the dev environment, we can run unit tests, and once these unit tests are successful, then the environment is promoted to the next stage, and this is the test environment. So the test environment, as you see, is not running a build. We just deploy the already tested code, and once this is done, here we can run tests. Then, for instance, we promote this code and deploy it to the UAT system. And the expectation, or what would be nice to have, for instance, that before it goes out to the production environment, there has to be like an approval from, for instance, from the release manager that, okay, is this application or is this feature ready? It can go live or not. And it can go to the production system or not. So basically, this is the functionality what we would like to implement as well. So let me just come here. So this application, what you see here in the background, is running on this Openshift environment. Let me just come to the workloads. So these are the pods. Let me just go here. As you see, I have created for you 3 projects. So there is one project what plays the dev environment. One is the test environment, and one is the production environment. And if you remember, let me just go here. Let's assess the production. No, I am very bold, so I will touch the production right now. So these are. Let me just group it for you so that we see it. So if you remember the architecture, this is the cart service, the catalog. This is the catalog's MongoDB. We have the cool store gateway. Then we have I will explain to you. So as you see, we have from inventory 2. But it has a reason. I will come back to this. But we have an inventory service with its own Postgres. There is the web UI, and then so this is our application. These are the pods what are actually behind this functionality. So if you remember, one of the things I told you that the microservices architecture would enable to you to actually scale independently your application components. So for instance, if there is a huge demand and a lot of people would like to have a look at what you are offering in your website, then you might want to scale the web UI part of it, but not necessarily, for instance, the inventory. And vice versa, or for instance, you need to, you have a backlog in the shipping, then in this case, you need to scale that component independently. So one part, what I wanted to also to show to you, that my expectation is from a microservices application that I can do changes to one component without actually affecting the other one. And one of the things what I can do is, for instance, a blue-green deployment. And what I have brought for you today in the demo is basically a blue-green deployment for one component in this application, in this microservices application. So I have 2 services here. One is tagged as blue, the other one is green, and basically we are using in production 1. And the CI/CD logic is the following. I have shown to you previously that I have deployed actually of Jenkins here. So this is my Jenkins pipeline supporting this application, this microservices application. So I have the following steps in it. There is a build. in the dev environment. We are running some tests in this environment. Then we are deploying to the test. We are running again some tests in this stage. Then there is a deploy, but not a live deploy to the production. This is when, if the blue is the active, then we deploy the new code as the green. We can do smoke test on this. And then there should be an approval and then a go live when the application is actually enabled, so that we have the route and it is pointing to the right service. So let's see how this goes. You can ask me the following question. Okay, we know Jenkins. By the way, you guys know Jenkins. I know that most of the people, even if they are not using a container platform, at least heard or already are using Jenkins for virtual machine-based deployment. So you can do a lot of fun stuff with it. And one of the things is that you create these nice pipelines. Here in this case, as I have shown to you, this Jenkins is running on the top of Openshift. Why this is actually an important factor. So if you have a Jenkins, an external Jenkins, then what you need to do is you need to have a lot of plugins, and then you need to go out, you need to configure, for instance, with Kubernetes, your Jenkins or with the outside world. So if you are a customer who would like to start right away with a fully fledged Jenkins, then you can do it with Openshift and on the top of Openshift. Why? Because the Jenkins comes already with the necessary plugins configured, and it is already configured together with Openshift to work with. What do I mean with it? So in order to create this pipeline, so I am showing to you this pipeline, usually people go here and then there is this configure, and you need to then basically, yeah, I just wanted to go here. So if you know Jenkins, then you know that in order to create like a Jenkins pipeline, you need to come here, you need to configure. So what are your parameters? Then you need to have your pipeline script. This is actually the logic, what the Jenkins is using for it. So if in this case, what I have done is that I was not clicking around. I am in general, I am believe more in a scripted way, because it's I build it once and I can redeploy it many times. So let me just go back here. So let me show you something. So we have this nice build config here. So what I have done, I have deployed the Jenkins on the top of Openshift. If you remember, Marta also has shown to you the commands like OC new app. It's very easy. It comes from a template. It comes from the Openshift inventory. And so this is a specific build config, but it's actually a Jenkins file. So if you have such a build config, I show you the YAML as well. I hope it doesn't look that nice, but so this is a build config. What is a specific type? It's actually it's actually a Jenkins pipeline. And as you see, the content is basically what I want to do. And the good thing is that if I upload this here, create this on the top of Openshift, it is automatically pushed to the Jenkins where I want to have it, and I can right away deploy the Jenkins, deploy the pipeline I want, and my CI/CD is up and running, just like I do it with Gogs and I do it with the Nexus. So let's just have a look at it. So I would like to right now kick in this. So for instance, here in this demo, I will show you how to do a blue-green deployment for the inventory, only for the inventory component. So I am right now, I am just clicking in. These are the build parameters. as you can see, I have these parameters for my project, like a test project, a prod, and the development. Let me just say that I want to build it. So I have kicked in this on my dev environments. In the meantime, I wanted to show to you what is this, how the pipeline script looks like. So basically, I am doing a build. So this is the build step. This is where you can do your unit test. Then we are deploying it on it. Sorry. Maybe it is better to show here. So we are actually deploying on it, deploying in the test environment, and run the test. So right now this is just a sleep, but you can include here the test, the actual test, what the Jenkins does. Then you can deploy to the production. This is where you actually tagging the blue-green deployments, and you are in the last step. You are basically the go live is basically just switching the services in the route backends. So let me just go back here. So as you see, the build is still running. So this is on my dev environment. If I go here and I come to the builds, this is on my dev environment. As you see, it is clicked in. So this is my inventory. So the build is up and running. I can see the logs that it is doing. So it is, this is as you remember, this is a Maven. This is a Java application, and it's a Maven right now. If you remember, I have a Nexus here. If you want to increase this, decrease this time so that it is not consuming even 2 minutes to build these Maven packages, then you can have the Nexus actually locally or on the top of your Openshift, and then this is even this goes even much more faster. So let me just expand this. Yeah, push successful. So it finished. This is the build on the dev environment. As you see, I am already running this 10-second test. Then I am deploying it right now on the test. As you remember, we are building only in the dev environment. Now we are running our test here. This is when we are deploying it to the prod. I am just trying to show it to you in the production. I hope I will be quick enough. Yeah, as you see, the old one is terminating and the new one is coming. So right now we are deploying here. As you see, these are the previous runs what I had. So it's this is the deploy. So I can show you the logs. So the deploy is actually a scale operation. So let me just go back here. It will be soon finished. Luckily, it's a consistent environment, so it doesn't take that much time.